Yes, Alif and Gauri. How are you guys?
Fine, sir.
All right. So previously we did completed one chapter. We completed the chapter friction. Okay. And today we'll be beginning with a new chapter. Okay, now. Okay. So I'm waiting for others also to join. Let us just wait for 1 or 2 minutes so others also join. Till then, you guys tell me which chapters from your syllabus are pending to be discussed. Gauri?
Sir, synthetic fiber and that pollution one. Wait a minute.
Okay. So synthetic fibers and plastics and pollution of air and water. Those two
Yeah.
chapters. Okay, for you, those two chapters are left. Okay, and what about you, Alif? You also do let me know. By the way, I have your syllabus. Okay, no, I will look into it. Just 1 minute. Let me all. Where are others? Let me just drop a reminder for others to join the class. Okay, now. Call others. Okay, let's start the class. It's already 5 minutes. So the chapter which we are going to begin today will be chemical effects of electric currents. All right, now. Both of you kindly confirm that you guys are having this chapter in your syllabus. The chapter chemical
Yes,
effects of electric currents. It is there now?
Yes, sir.
Okay. So in the chapter, there are lots of different things we should be learning. Previously, you guys would have, in your earlier classes, you would have learned that there are some solid materials that allows current to pass through them. Right? In your class 7th standard, also you would have learned about these things, that there are some solid materials that allows electricity to pass through them. Right? And we were calling them as good conductors of electricity. They are called as conductors of electricity, right? And then we have certain materials which do not allow electric current to pass through them easily, and we were calling them as poor conductors of electricity, or basically non-conductors or insulators of electricity, right? Gauri and Alif.
Yes, sir.
Okay, na? Okay. So like for example, you have examples of metals like copper or aluminum. They will allow electricity to pass through them very easily, so they are called as
Sir,
good conductors.
Sir, water is a conductor, right?
Water, polluted water is
But it's not
conductor,
solid.
but it's not. Usually a
It's
water
not
that,
solid.
yeah, usually it is okay. It is not used as a conductor. Not used as a conducting material for passing electricity. Okay, now because it is unsafe. Okay, now because of its nature, it is unsafe to use water as a conducting material. Okay, now so it can't be used for
Okay,
transmitting
sir.
the electricity from in place of electrical cables. It can't be used. Okay. Also, while we will be learning about whether water is what kind of water is a conducting will conduct the electricity, there we will get to learn about that in detail. That only impure water will conduct electricity. Distilled water will not conduct electricity. Okay, no. Anyways, talking about the basic things. Moments ago, we learned like we have copper, aluminum. They are good conductors of electricity. Then on the other hand, we have materials like rubber, like plastic or wood that do not allow electric current to pass through them. So thereby they are poor conductors of electricity. In other terms, also called as insulators of electricity, right? Okay, no? Okay. And I believe that in your 7th standard, you would have learned about some experiments also. some tests also. In your school also, you might have done some tests in order to check the conductivity of different solid materials. Right now, how can we check whether a given material is conductor or not? Can you guys suggest me a setup how we can check whether a given material is a conductor of electricity or a insulator? What can we do? We can take some wire, connect it to a battery or a cell. Okay. On the other hand, we will connect a bulb. Okay. We will connect a bulb. Now over here, I will connect the different materials to be tested whether it is a conductor of electricity or bad conductor of electricity. Getting it, guys? So say that I have taken a material. If the bulb glows, then this material is called as a conductor, right now?
Yes, sir.
And if the bulb does not glow, so thereby it will say that this material is a insulator. If the bulb does not glow, thereby it will be insulator. Or if the bulb glows but it gives a dim light, okay, it gives you a dim light, so thereby it will be not considered as a good conductor. Okay, now it will be a bad conductor, usually not a very good conductor. So that was the simple test to check the conductivity of a given substance. So that thing you would have learned in the previous classes. And in the previous classes, in your previous 7th standard, you would have learned only about the test being conducted to check the electrical conductivity of solid materials like metals or like wood. Okay, now. But interestingly, in this standard, in this class, we would be learning about the electrical conductivity of liquids. Okay, now earlier you had learned about electrical conductivity of solid materials. In this class, you'll be learning about electrical conductivity of liquid materials also. Getting it, guys? So that is something new which you would be learning in this class, in this chapter particularly. Okay. So let us first of all get our basics clear. Okay, now let us get the basics clear. So first of all, we are going to be learning about conductors and insulators in this chapter. We'll be learning about water conductors and water insulators. Okay. Before we move on further, let me just give you a brief overview of the different topics that we are going to be covering in this chapter. Okay. And I think that you guys should note this down in your copies. Okay. I'm going to provide you content of the chapter. By the way, is this a black background more comfortable, or was the white background more comfortable for you guys?
White one.
White one.
Yes,
Okay.
sir.
Okay, is that the case? Okay, just give me a moment. I will change the color. Now is it better?
Yes, sir.
Okay, good.
Yes, sir.
So first of all, you guys write down the content of the chapter, the different things that we guys are going to learn in the chapter. So in the content, first of all, write about conductors, then insulators, water conductors, water insulators. Okay, now you'd be learning about those things. Okay, and after this, we'd be learning about a little bit. We'd be learning about electrons also. Okay, now in this you'd learn about electrons also. What are electrons and what is their role? So you'd be learning about that also. And furthermore, there's a small concept that is ions. So you guys would be learning about this thing also. What are ions? Okay, these are some basic terminologies like electrons and ions. These are very small concepts, which if you guys get to know, then it will be easier for you to understand the different concepts in the chapter. Okay. Then later on, we'll be learning about conduction in electricity. conduction in electricity. Okay, there you would be learning about distilled water or impure water, or water that has acid in it, okay, now, or a water that has base dissolved in it right now. So will they be conducting electricity or not? Okay, Chakrika is also here. Okay, so you'd be learning about different kind of liquids like lemon water or vinegar or like tap water or mercury, which is also a liquid metal. So whether they are good conductors of electricity or not, all those things you'd be learning here. Okay. So, and also you'd be learning about how liquids would be conducting electricity. Okay. Yes, Chakrika, how are you?
How are you?
Yes, I'm also good. Okay, please try to join the class on time. Okay.
Yes,
So
sir.
then we would be learning about how the liquids would be conducting electricity. By the way, Chakrika, we have started this chapter, chemical effects of electric currents. Okay, na? So this is the chapter which is going on currently.
Yes, sir.
And I suppose this chapter is there for you also, no? If I'm
No,
not
sir.
wrong.
No, sir. It was not there in the textbook.
It was not there.
Yes,
Okay,
sir.
okay. But anyways, in your final exams, you'll be having this. Okay, no? And by the way, you had the backup class for the chapter materials, metals, and non-metals or not?
No, sir. I didn't have.
Okay. Okay. Because I'm asking because earlier you told me that you would be having some backup class on that day. Okay, I will consult the team regarding this. Okay, now. So I'm right now giving the different topics which we would be learning in this chapter. Chakrika, you also note down all these topics. Okay. So we'd be learning about. Sorry, I should have written conduction in liquids actually. Okay. Conduction of electricity in liquids. So we'd be learning about this thing, how the liquids would be conducting electricity, why certain kind of liquids will conduct electricity while other kinds of liquid will not conduct electricity. Right now, why salt water, why distilled water will be a very bad conductor of electricity, but salt water will be a good conductor of electricity. All those things we would be learning about that in detail. Then we would be learning about that why LED bulbs are more suitable for testing the electrical conductivity of liquids. Like moments ago, I draw a setup. Right now, here, this is the test material. This is the cell. This is the cell, and this is a bulb. And we basically use a LED bulb in order to check whether a given substance is a conductor of electricity or not. So we'll be learning about that in detail. Why we didn't use any other bulb in place of this LED bulb to check whether a given material is a conductor of electricity or not. Getting it, guys? So we'll be learning about such concepts. Okay, the use of LED bulb to test electrical conductivity. So this is something we should be learning. I suppose both of you guys, all of you are writing down all these important points. Okay. So you'd be learning
Yes,
about
sir.
this thing also, right? Then later on, in this we'd be doing some activities also. Okay, now in conduction of electricity and liquids, in this you guys would be learning about some activity. So in bracket, write down this activity also. Okay, where we'd be learning about weak and strong conductors of electricity. Okay. Then after this, you'd be learning about concepts like what is electrolysis. Okay, no? Electrolysis. Under electrolysis, there are some subtopics which you guys would be learning about. Like you'd learn about what are electrodes, what is electrodes. Then you'd be learning about concepts like what is electrolyte. Okay. Then after this, you'd be learning about concepts of anode and cathode, and you'll be learning about anion and cation. Okay, anion and cation. So these things you would be learning. Okay. Later on, you would be learning about effects of electric current. Effects of electric current. That whenever there will be a flow of electricity right now, then what effect will it produce? I suppose in your seventh standard, all of you would have studied about magnetic effect of electric current, right? Whenever electricity flows in a wire, it generates a magnetic field around it, and thereby has the tendency to,
Electromagnet, right?
yeah, electromagnets are there. Okay, it is based on that principle. Okay, what I'm saying that you have a electrical wire. If current is flowing in this electrical wire, so it will generate a field of magnetism. A magnetic field generates around it. So it has the tendency to attract or show some deflection if you were to place a magnetic object in its magnetic field. Right now, although for deflection to be visible, the magnitude of magnetic field has to be too much. What I mean to say that, say that there's a electrical wire in which current is flowing. So current is flowing in this. So thereby it will generate a magnetic field around it like this. Magnetic, these are the magnetic field lines, by the way. We should, a concept we should be learning about in more detail in when you go to the class 9th standard. Okay, na? There you'd be learning about certain laws also. Okay, na? You'd be learning about several kind of laws in class 9th standard. Anyways, so this is the magnetic field, right? So if you happen to place a magnetic compass within this magnetic field, so the needle of the magnetic compass starts to show some deflection now. This is the needle of the magnetic compass, and it starts to move towards the it starts to show some movement. Getting it now? Because this needle is also magnetic, right now. So due to flow of current, a magnetic field is generated, and this is called as magnetic effect of electric current. You guys getting this now? I think you all would have learned about this in the previous class, right? In this class, we
Yes,
would be
sir.
more concerned with the chemical effects. This is a physical effect of electric current. Okay, now, as the chapter name is chemical effects, so we'd be learning about chemical effects of electric current. Okay, now, so talking about the chemical effects of electric currents. So there we will see that when current will flow in a wire, right now, so it can sometimes produce bubbles, right? It can change the color of the appliance permanently, right? It can lead to heating of the substance. Getting it, guys? Or it can lead to production of some chemical energy and can lead to some chemical reactions also. So those will be the chemical effects of electric currents we should be particularly learning about. Okay, no? And it will have some applications also, like electroplating. I suppose all of you know about galvanization, right?
Yes,
One
sir.
of one of you please go on and explain this. Just anyone please explain galvanization.
Sir, is that like the process in which iron is coated with zinc or something?
Zinc. That is
Yeah.
galvanization, right now. So a layer of one metal is coated over another metal. So that is done by electroplating, in which electrical current is used. Okay, na? Getting it? So that's a chemical process being carried out with the help of electricity. So in the effects of electric current, we will learn about what are the effects it produces. Then later on, we'll be learning about its applications also. Okay. Applications. of electric current. Just write down applications only, okay? Applications. I know some of this topic you guys would be confused as of now. Okay, now there are several topics in this which you guys will it will be cleared once the chapter will be finished. Okay, now. So as of now, just write down all these things. Okay, now. In application, after you guys would be done writing all this, please let me know. There are few more important, few more topics you guys have to write down.
Done, sir.
Okay, all of you, Chakrika, Alif, and Gauri.
Yes, sir.
Yes, sir.
Okay, Chakrika, you also done? You aren't. You are hardly audible, Chakrika.
Yes, sir.
Oh, okay. Hmm. Yeah. Talking about applications, there you would be learning about electroplating. What is electroplating? Right now, so we'd be learning about electroplating and its process. What is electroplating and what is its process? There would be learning about this. Okay, now. Furthermore, we would be learning about applications of electroplating. What are its application? As we have examples of galvanization, or you'd have seen that certain parts of the machines would be plated with another metal in order to prevent it from rusting or in order to make it stronger. Okay, now. Furthermore, we would be learning about some other applications of chemical effect of electric current, like in extraction of metal also we take help of this chemical effect of electric current. Okay, na? So there also you'd be learning about. Then later on you'd be learning about purification of metal. Purification of metal is also done. Okay. Then later on you'd be learning about this one, production of compounds. We can create new compounds with the method of electrolysis. That we would be learning in the chapter. Okay. Later on, you'd be learning about decomposition of compounds. Decomposition of compounds. You guys do let me know once you know all of it be done. Okay. All of you have seen that the tap water, the tap would be electroplated usually with chromium. The tap that you see, it has a very shiny, it is very lustrous, no? It is very shiny.
Yes, sir.
So that it is shiny because of chromium. Chromium is plated over it. If you were to scratch it with a very sharp object, the chromium will be scratched and then iron will be exposed. Okay, na? Chromium, by the way, can be even plated over plastic objects. The door handles of the car, that is also plated with chromium. Okay.
Done, sir.
All of you done? If everyone done, please raise your hand in the class. Okay, Roni is joining at this time. All right then. Let us move on to the concept of conductors and insulators. Okay. So talking about conductors and insulators. So this term conductors and insulators is taken into two contexts. One, where they are conducting electricity. In another context, it is used for used in terms of heat also. So right now we are talking about conduction of electricity and not that of heat. So on the basis of whether an object will allow the electrons to pass through it, right now, or whether in general we see that whether it will allow electricity to flow through it. On that basis, we have two kind of substances, two kind of objects. Okay, now. Yes, Roni, where you have been? You are joining almost half an hour late. And all of you turn your cameras on in the class. Alif, Gauri, Chakrika, and Roni. All of you kindly turn your cameras on in the class. Do let me know that you guys are there in the class. Okay, Roni, I understand. Okay, then it's fine. Talking about on the base, whether a given substance will allow the electricity to pass through it, or whether it will not allow the electricity to pass through it, right? On that basis, we have got two kind of materials. One is conductor, another one is insulator. Okay. Gauri, please read the given paragraph.
Okay, sir. A conductor is any material or substance that allows electricity to flow through it. An insulator is any substance or a material that prevents the flow of electricity through it. Any substance can be called as a conductor of electricity if it's allow movement of charges through it. The electrons of the conductor can flow freely. They are delocalized and hence can take electric current through them. Insulators do not allow the flow of charges through them because their electrons are tightly packed with their particles.
Okay. So the general thing I think is, I suppose it's clear to everyone. Any given material that will allow the electrons to pass through it. For example, you have a iron rod. So in this iron rod, electrons will be able to pass from one end to another end. Okay. While you have a piece of wood over here, so you have a wood over here. So the wood will not allow the electrons to pass from one end to another. Right now, it allows while the another one does not allow. That is the basis of classifying the objects, whether it's a conductor or bad conductor of electricity. Bad conductor, we also use the term insulator in place of bad conductor. Another important concept is that electrons of the conductors are delocalized while electrons of non-conductors are tightly packed. So what does this mean? This statement might be a bit confusing to you guys. See, if you were to look at the electrons of the conductors, so they are not tightly packed. They are loosely bound, and as you can see in this image, they are delocalized. Like some of the electrons over here, the one that you see in the smaller dot now, the smaller circle that represents the electrons. Okay, now. So there is a sea of free electrons over here. What do we see that there is? Sea of free electrons. Getting the concept, basic concept, what I'm trying to say. The electrons are free to move anywhere in a conductor. They are free to move anywhere. Getting it, everyone? So for example, try to understand in this manner. Like this, all these electrons can move, for example, in this direction. All the electrons can move in this direction. Can you guys see the arrows I'm trying to draw over here?
Yes, sir.
So they are free to move anywhere in a conductor. Over here, like this. But in the case of a insulator, if I were to show you the setup of the how electrons would be there in the case of a insulator. So there we will get to see that it will be tightly packed like this. Say for example, say that this is the structure of a insulator. The previous one we discussed was that of a conductor. Okay. By the way, electrons carries negative charge. I think all of you knows this thing. Electron is a subatomic particle, right, found within the atom, and they are negatively charged. So just have a look at this. See, the smaller dots that I'm drawing, these are the electrons. And aren't they very tightly packed? Yes. Don't they look like they are very tightly packed? So the electrons in the insulators are not able to move freely. They are not able to flow freely. Getting it now? While in the case of the conductors, the electrons are able to freely move here and there because they are delocalized, not fixed at one place. They can move from here to there. So thereby they can conduct electricity. And all of you know that electricity is generated due to flow of electrons now. What is electricity? Electricity is generated due to flow of electrons. Hope you guys are getting this. Yes or no? Please let me know this.
Yes, sir.
Okay. I hope this thing is clear to everyone.
Yes, sir.
On that basis, we have classified. Okay. Chakrika, read the given paragraph.
Yes, sir. Some materials can allow only a little flow of electricity through them and are called poor conductors of electricity. Some materials can allow the complete flow of electricity through them and are called good conductors of electricity. Every material may conduct electricity in certain situations. For example, air is a bad conductor of electricity. But in case of thunderstorms and lightning, it carries electric charges through it. Hence, materials are always classified as good and poor conductors of electricity, rather than conductors and insulators.
See, a very important concept to understand here is that, see, although we know that air is a bad conductor, okay now, although in normal situation it is a bad conductor, but we don't say that it is a non-conductor. We don't say it to be a non-conductor. We say that it's a bad conductor. Bad conductor or a non-conductor, these are two different terms. Getting it, guys? If it's a non-conductor, it will never conduct electricity. But if it's a bad conductor, it means that in certain situation it can conduct electricity. Getting it now? So thereby, materials are always classified as good and poor conductors of electricity rather than calling them as conductors and insulators. Because in the case of thunderstorm, air being a bad conductor of electricity, what happens when there's a thunderstorm? So much of charge is generated, that air will conduct the electricity in that case, because the magnitude of charge generated is so much that in thunderstorms air will conduct electricity despite it being a bad conductor. Okay now? So what happens now? Basically, the molecules of the airs, like air also has molecules, isn't it? Getting it, guys? Air is also a molecule. Air also consists of molecules. So in thunderstorms, what will happen? That the molecules of the air, they are also ionized. They are also ionized. What happens basically? Their kind of electrons are taken away from them. What I'm trying to say that they will become positively charged. The molecules of the air will become positively charged in the case of a thunderstorm. Getting it, guys?
Yes,
So
sir.
all of this will become, just 1 minute here. All the molecules of air will become positively charged, and thunderstorm will carry lots of electrons in them. And electrons are negatively charged now. Electrons are negatively charged. Getting it, guys? And you guys tell me about this. I think you guys would have studied about this, huh? Do tell me, from where electricity flows, from positive to negative or from negative to positive?
Negative to positive.
Hmm?
Negative. Sorry, positive to negative.
No, it flows from negative to positive now. The direction of current, the direction of the flow of electricity is, in reality, it is from negative to positive. In reality, I am telling. Okay, now. So electricity will be flowing. So the molecules of the airs have become positively charged, while the thunderstorm, it has negative charges. So thereby electricity will flow into it. So in such a situation, so much of charge is produced that the air behaves as a conductor of electricity in that scenario. So hope this is clear. Is this concept clear to everyone?
Yes, sir.
Yes, sir.
Good. Although we see that air is a bad conductor, but it can conduct electricity during thunderstorms. All right. Then we have several examples of objects that are conductors and bad conductors. Okay. So we have like silver, gold, copper, steel, or seawater. Seawater is saline, it is salty. So these are the good conductors of electricity, right? And then we have several examples of objects like rubber, glass, oil, diamond, or dry wood. They are bad conductor of electricity. Now note down over here that there is dry wood over here. So will the wet wood conduct electricity? Think about this. Will the wet wood be conducting electricity?
Yes, sir.
Be conducting
But
electricity.
bad conductor, right?
But not a very good conductor, but usually a bad conductor. But it will conduct some amount of electricity, right now. So taken as an insulator, dry would be considered as an insulator. So hope you guys have understood this. Okay. Then another thing we are going to learn about conduction of electricity in liquids, like whether liquids would be conducting electricity or not. Okay. Just talking about this concept that not all the liquids should be conducting electricity, but there are some liquids that we regard as good conductors of electricity, while some of them are regarded as poor conductor of electricity. Like for example, have a look at this chart, hmm, where we have distilled water as good conductor of as poor conductor of electricity. Tap water is good conductor. So note down the ones that I'm going to highlight. Tap water is a good conductor. Lemon juice is a good conductor. Vinegar, poor conductor. Okay, na? Cooking oils, good conductor. Milk is also a good conductor. Soda compounds are good conductor. Mercury is a good conductor. Okay. What do we generally note down about these different materials?
Sir,
What? Yes.
sir,
Yeah, I'm
is
listening.
like soap water is good conductor or bad conductor?
It's a good conductor. Okay.
Okay.
Because soap solution contains bases in them. Okay, na? And when you add base into water, and when you add acid into water, or when you add salt into water, so they were that water will become a good conductor of electricity. Okay, now?
Now I have a doubt.
Yes.
So here it is mentioned that cooking oils are good conductor.
Yeah, cooking oils are good conductors.
But then in the previous one, it's in electric insulators, oil is mentioned. In that case, which oil is mentioned over there?
Over there, no, I think it is being referred to fuel oil usually. Fuel oil is being referred. Okay, no, Chakrika.
Yes,
So
sir.
cooking oils are good conductors of electricity. Okay, because it will not all of them, I would say. There would be in this also there will be several exceptions. Okay, no. Like for example, coconut oil. It's not a very good conductor of electricity. Okay, so it's not like necessarily all the vegetable oils, all the vegetable oils, or all the cooking oils would be good conductor. Okay, no. But some of them would be good conductors. Okay, no. Some of them would be good conductors.
Yes,
Hope you
sir.
guys are getting this. Okay. So because there are exceptions everywhere, we can't generalize everything in chemistry. Okay, na? In chemistry, you will have experience in every concept. Anyways, Now, the most important thing for a given substance to conduct electricity is now that it should have ions in it. Remember moments ago, while I was providing you with the content which you guys would be learning, there I did noted that you would be learning about electrons and ions. So it is important to first of all understand about ions. Okay, now see, let us understand it with the example of these two liquids. Here we have water which contains impurities, another water that is distilled water which does not contain any impurity. Okay, now. So first of all, let us understand the concept of ions. Ions, talking about ions, ions are charged particles. What are they? They are charged particles. Getting it now? So basically, any atom which has a positive charge or which has a negative charge will be called as ion. Let us try to understand it in this manner. I think you all would have learned about this thing about electrostatic charges in your previous classes. Like when you rub a piece of ruler on your hair, it develops some charges and then it can attract tiny pieces of paper. Or when you rub a balloon with a silk cloth, and when you bring two balloons together, they will be repelling against each other, right? Or if you were to put it to the wall, it will be sticking to the wall. And you would have performed those activities as a kid. There, basically what happens now, say we have a given substance, for example, let us say you have taken a ruler, a plastic ruler. So when you are rubbing it with some cloth, right, or you would have learned about ebonite rod also, particularly about that you would have learned. So say that you have taken a plastic ruler. What we are trying to learn right now, we are trying to learn the concept of ions first of all. Let me just take a different page. We are learning about the concept of ions. Ions are charged particles, basically. Okay, charged particles. And particle here is being referred to the atoms. Okay, now atoms or molecules. Okay, two types of charges are there, positive and negative. So first of all, let us take example of a plastic ruler. And this plastic ruler, you are rubbing it on some cloth on your hair. So what happens now? As we know that every object that we see around us are made up of the fundamental unit called as the structural, and the smallest unit called as atoms, right? Getting it, guys? Atoms are the most fundamental and smallest unit of anything that you see around us.
Yes, sir.
Right? That is a basic thing. And we know that if you were to look at the structure of the atoms, atoms further have got several particles in them. See, this is the, I'm right now trying to draw the structure of an atom. Let me just clean this over here. Okay, so try to understand this. So this will be this will usually be the structure of the atom. Okay, now right here I have drawn the structure of atom. Now an atom further contains some smaller particles in them which are called as subatomic particles. Okay, so those subatomic particles are namely three. So the one that you see in the black color, this is called as electrons. This is called as electrons, and it has negative charge on it. It is negatively charged. Getting it? And it is free to move. So this will be moving in this orbit. You see this orbit? So it will be moving in this orbit. Getting it, guys? Now, this central structure that you see now, this is called as the nucleus. And in the nucleus of the atom, there are another two subatomic particles. One of them is called as neutron. Another one of them is called as proton. Is that much clear clear to everyone so far? Proton are positively charged. Neutron has 0 charges on them. Getting it, everyone, so far?
Yes, sir.
Now, normally what happens now, when a given substance is undisturbed, like you are not doing any kind of disturbance to this piece of ruler, okay, na? So in that situation, what will happen? The amount of proton and neutron will be equal. Okay. So naturally, a given substance is stable. It is, say, if it is undisturbed, so thereby it is in its neutral state. At that time, the number of proton will be equal to number of neutron. So at that time, there won't be any charge on the atom. It will be neutral, neither a positive charge, neither negative charge. All if you're getting this, what I'm trying to say?
Sir, I didn't get it.
Not getting it. See, what I'm saying that when an atom is left undisturbed, then it is neutral state. It is in a neutral state. What does it being in a neutral state mean? Huh? So when the number has have I written neutron in place of this? Sorry, just let me do one correction. Over here, I should have written actually electron. I mean to say, okay, now electron. Electrons are negatively charged now. Protons are positively charged, as we know. So when an atom is in a neutral state, so then it has equal number of proton and neutron in it. The number of proton and electrons, I mean to say, proton and electrons would be equal. So thereby, let us say that we have the atom of sodium. We have atom of sodium. So atom of sodium will have 11 protons and 11 electron. Or can I say that since one proton will have one charge on it, or one electron will have one charge on it. So 11 proton, try to understand what I'm saying, that one proton will carry how many positive charges? It will carry one positive charge. Getting it, guys? And same thing is that one electron will have one negative charge. Okay, now? So if there are 11 protons, so there were how many charges are there? 11 positive charges now.
Yes, sir.
And if there are 11 electrons, there will be 11 negative charges. So the number of charges are equal. The positive and negative charges are equal. So in that case, we see that the atom is in a neutral state. Okay. Hope that is clear. Getting it now?
Yes, sir. What if the charges for each for electron and proton are different?
Okay, yeah. What if their number is changed now? That's what you're trying to ask.
Yes, sir.
Then they will become charged. They will be either become positively or negatively charged. So now try to understand another important concept over here. Say that if due to some external disturbance, like you are rubbing this atom, this let's say this is an atom of a ruler, of a scale. So if you were to rub that, so that is an external disturbance. You are disturbing it. So the atoms would be disturbed. So either the number of electrons can increase or either it can decrease. How it happens, we're not going to go into that much of depth. Okay, na? So if the number of electron increases from, let us say, from 11 to 12, for example, so this sodium would become, overall, this will become negatively charged now. Getting it, guys, what I'm trying to say? Like now
Yes, sir.
what happens now? Earlier what I'm saying, let me take another page over here. Earlier what I mentioned over here, that say that we have a sodium, or let us just take any other atom for the sake of convenience. Okay, now let us take an element A. Okay, earlier on this element A, the number of protons were equal to number of electrons, right? So the number of positive charges were equal to the number of electric charges. So it was in a neutral state now, right? So at this place, it is in a neutral state. Hope everyone is getting this. Now, due to some disturbance, let us say we are disturbing it. So in that case, what will happen? Let us say that the number of electron increases from 1 to now 2. So you guys tell me the overall net charge on this element is negative or positive? The overall charges?
So can you repeat?
The overall charge on this element will now be negative or positive?
Positive.
No. Overall charge, you will be calculating it as total electrons minus total protons. Total electrons are 2. Proton was 1 now. Getting it? There are 2 electrons now over here. You guys not getting this? There are 2 electrons now. There's 1 proton now. Right? 2 electrons means that 2 negative charges. 1 proton means 1 positive charges. Didn't we learn about this? 1 proton has 1 charge, 1 electron has 1 charge. So 2 electrons means 2 charge now, 2 negative charge. 1 proton means 1 positive charge. So 2 minus 1, that is 1 electron. Getting it, no? So thereby overall charges negative on it. So that element is now said to be a charged particle. Now we say it as a charged particle. So thereby, rather than calling it as charged particle, we call this as element. Getting it? So when the number of proton or electron is disturbed, it is changed, then the atom is called an ion. Is that concept clear to everyone or not? Please do let me know.
Yes, sir.
Okay. If it's clear to everyone, please raise your hand in the class. All right, that's good. So hope that basic concept is clear. That was very important in order to understand this concept further. Okay, now. So now we can say that a given liquid will conduct electricity when it will develop ions into it. Okay, now when ions will be formed in a liquid, in that situation it will conduct water. Okay, now. So water that will have some impurities. Okay, now. If water have some impurities, it helps in formation of more ions. Okay, now. Getting it, guys? So a liquid will conduct water when ions are formed in it. Getting it? When ions are formed into it. That is the basic concept. Okay. So this is a liquid that has some impurities. This is like a liquid that has some impurities in it. For example, these are the impure particles in it. Let us say they are sand, or you have added some salt in it, or you have added some other substances in it, right? So it becomes easy for electrons to flow in it right now. So water with impurities helps in formation of ions. So if ions are formed in a given liquid, so it will be easy for the flow of electricity. Getting it now? So it's the ions that will allow electricity to pass from one place to another in a water. And if there's a distilled water, there isn't any impurity. You haven't added salt in it, or you haven't added sand or mud in it. So thereby, it's a clean water right now. So there's only molecules of water in it. There is no other unwanted substance. In your sixth standard, you would have studied about pure and impure substances, right now? Right? All the metals are pure substances. Are alloys pure substance or impure substance? Alloys are impure substance, no? A pure substance is a substance that is made up of only one kind of particle. Like this distilled water only contains molecules of water, no?
Yes, sir.
Molecules of water. So same kind of, only one kind of material is found in this water. While this impure water, it contains, let us say it has some sand, some soil particles are in it, along with water in this. So several kind of materials are found in this, hence it is impure. So impure water helps in formation of ions, thereby a water that will have ions in it will conduct electricity. So thereby, in water, you can add anything. For example, in a given liquid, if it will form ions, then it will be conducting electricity. So although not all liquids can conduct electricity, however, some of them can be regarded as good conductors of electricity. Right now.